Okay. So basically today we will discuss about the DFM report. Acha, what is the meaning of DFM report? As I told you, design for manufacturing. है ना? It is like a feasibility report for the component, that the component is feasible or not for the molding process, right? So basically a DFM report shows few information about the component, right? Okay. So what and why? What is the DFM report and why we need DFM report? This is the main question of main questions, right? Okay, see here. One minute. So DFM means, as I told you, design for manufacturing. Design for manufacturing, right? So basically, for example, if you are designing a component, for example, a CAD designer design a component, right? But what is the purpose of designing that component? Basically, we are going to manufacture that component by the molding process, by the injection molding process. So that component should be suitable or feasible for the molding, right or wrong? Right or wrong? Right?
Yes, sir.
So that's why, for example, if we are designing the component, so it should be feasible for the molding process, right? है ना? So what you understand about this point? What you understood about this point? That, for example, if you are a CAD designer, if you are going to design a component, so before designing the component, you should have knowledge about the mold manufacturing, right or wrong? So you should have knowledge about the tooling or the fabrication, you can say that, right or wrong?
Yes.
Okay, well, a little knowledge you should have, but you should have knowledge about that, है ना? Before start the designing of any type of, tell me. It is like a bridge. It is like a bridge between the product developer. The product developer is like a engineer, right? Who is design the product, right or wrong? And the mold maker. Mold maker means, you can say that they are designing the mold for that specific product, right? Right? So this is DFM is just like a bridge between them. Right? Understood? Hai? Okay. So basically you can see that in manufacturing industry, it is an effective way to increase efficiency. DFM is the process for designing component, which is, as I told you, which is easy for manufacturing, for high quality product at a lower cost. The goal of the DFM is to reduce the production cost, improve quality, and increase efficiency. This is very important points here. Acha, how this point is possible? Tell me. By the DFM report, reduce the production cost, improve the product quality, and increase the efficiency also. How? Tell me. Because before the mold manufacturing, we know already about the component, few information about the component, right? That can be wrong during the mold design or the mold manufacturing, right or wrong? For
Yes,
example, if this is the component, okay, and component has a larger wall thickness, for example, like this. This wall thickness is about to 4 mm. That is not required. Okay, and this wall thickness is about to 1.5 mm. And because of this larger wall thickness, what kind of defect can be produced? Tell me. Sink mark can be. Right or wrong? Or unwanted warpage? If we not require this non-uniform wall thickness, right? So we will prepare the wall thickness uniform, right or wrong?
yes, sir.
है ना? Right? So, okay? So by which we can improve the quality of the product. Quality of the product, right? Okay, for example, if we are dealing with the new product design and development, for example, we are designing the new product, or the company or the customer designing a new product. So this is the questions which will arise during the designing. What method we will use for molding, and it is cost effective or not? Is it risky For example, if we are using slider or the lifter mechanism, so it can be break during the production, right? And few more questions about that, right? So you can say that DFM provide the all the answer of this type of questions, right? Okay, so that's why DFM is a solution for this type of questions, right?
Yes.
Understood?
Okay.
Okay, so the DFM report is very important, right? है ना? Understood? है ना? As I told you, design for manufacturing. Why design for manufacturing? है ना? Design, product design is compatible with the manufacturing process or not. So basically, it helps to ensure that the product design is compatible with the manufacturing process. About the mold, right? That the final product will meet the desired quality standards, right? And right or wrong? And as I told you, DFM is important for the new mold projects. If I am talking about the new mold projects, it means we are dealing with the NPD products, है ना, which is not exist into the market right now. Okay, NPD means new product design. Okay, and if we are dealing with the new product, so basically there is a new problems has been occurred into the during the production of that component, right? Can be. So basically, DFM report used to predict that type of defects into that component, right? So for the prediction purpose, we have to use the flow analysis software also, right? For the proper prediction, we have to use the flow analysis software also, right? Okay.
Yes.
Okay. So because it helped to identify potential design and the manufacturing issues, right? Before the mold produce, right? Okay. And it helped to minimize the time and the cost of manufacturing process and can improve the product yield rate, right? And points for the DFM. What will be the points? And if I am talking about the DFM, so basically DFM we can prepare for the product design and as well as for the manufacturing process, right? Manufacturing. If we are dealing with the product design, so basically we are dealing with the plastic material, right? And if I am talking about the manufacturing process, means we are dealing with mold, right? So basically we have to prepare the DFM report for the product design, right? For the product right now, because we are going to prepare a mold for that specific component. That's why the DFM report analysis includes the detailed examination of the product design, right, and the manufacturing process of that. Okay. So basically it will deal with the mold design also. Right or wrong? Understood? So first of all, we have to prepare the DFM report after the production, after the complete design of the product, right? Or before the mold design, we should provide the DFM report to the customer, right? That feasibility is there or not, right? Okay.
Yes,
So
sir.
what is the point for the DFM report? See, these all are the points. है ना? These all are the points. See here, part detail, design features in product or any type of features which is difficult to eject from the mold, right? During the mold operation. So we have to mention that type of features, right? And third point is draft angle. And also what will be in the part detail, like part weight, part material, what we will take the shrinkage consideration for that, right? है ना? Okay, if we are adding few GF material in order to increase the viscosity of the plastic, right? So we have to mention in the part detail, right? है ना? Design features in the product like external or the internal undercut, as I told you, right? Any type of undercuts or any type of you can say that any type of features or the areas, right, which is difficult for the ejection, right? So that we have to mention in the DFM, right? And the draft angles, है ना? Why we take the draft angle points? Tell me.
To eject the part?
No. Draft angle, basically if we analyze the draft angle, so basically it ensures the core and cavity region, right? है ना? अच्छा, we have seen into the single soap case component, right? About that,
Yes.
where draft will meet, for example, if the negative and the positive draft will meet, you will get the parting line, right?
Yes, sir.
है ना.
Yes.
Wall thickness, so basically if I'm talking about the wall thickness of the product, है ना, which is for the molding purpose, right? So basically wall thickness should be uniform always, है ना, but there is a limitation of that. That is right or wrong, है ना. Depending upon the component application or the requirement, it is not a constant wall thickness we will get from the component, right? The wall thickness can be vary, but ideally you can say that it should be uniform, right? Okay. A and B surface. What is the meaning of A surface and the B surface? A is the cavity surface, B is the core surface. So basically,
Core surface.
right? है ना, mold draw direction. It is showing that where is the direction of the ejection of the component, you can say that. Where will be the direction of the ejection of the component will be the draw direction. Though it will also show the core and cavity region or the fixed half and the moving half of the component. Right? Tentative runner and the gate position. So basically it will show the best position for the runner and the gate. Okay, and for that we have to give the option to the customer that we should take this type of runner like 1 and we should take this type of runner like 2, है ना. Ejection analysis, so depending upon the component application or the appearance, we have to select the ejection. So before the ejection, selection of the ejection we have to discuss with the customer also, right? And last one point is molding defect prediction. Acha, in previous lecture we have discussed about the defects, right? Which type of defect we have discussed? Tell me. Tell me which type of defect we have discussed. Yesterday we have discussed, right? Like weld line, warpage, voids,
Vacuum voids and
sink mark, right? And this all are the type of defect. So we have to predict by the flow analysis software that this type of defect can be produced into the component. So we have to take the prediction of that, right? Okay.
yes.
So check the one by one. So basically this all the points are very important for tool design engineer, right? If you are going to design a mold for a specific component, so basically you should have knowledge about these points, है ना. For example, I am taking this fan component, okay, है ना. Now see part detail, है ना. See here. So basically in part detail you have to show part dimensions, part average wall thickness, part weight, plastic material, shrinkage considered, and the part 3D data and the number of cavities, है ना. How much number of cavities you want, है ना. So basically this information you have to show into the DFM. See here, है ना. So basically this is all about the part specification, right? About this component as I told you, right? है ना. Now again, है ना, if I am talking about the part dimension means length, width and the height. What is the overall length, width and height? And part average wall thickness means what is the maximum wall thickness and what is the average wall thickness. है ना, we have to show that, right? है ना. Part weight means why part weight? Tell me. For verifying the short capacity of the injection molding machine, we should have knowledge about the part weight also, right? For verifying the short capacity, right?
Yes.
है ना. Plastic material property. Depending upon the specific plastic material, we have to design the specific mold. Is it clear? Is it clear? Okay, understood. So we should have knowledge about the plastic material, that what plastic material we are using for making the component, right? है ना. Shrinkage considered. Depending upon the material. For example, if we are adding some GF material, as I told you, if we are adding few other material into the component, or the material is composite, for example, so basically shrinkage can be differ depending upon that material, right? Okay. Part 3D data, it should be ready. है ना. 3D data, it means like step, like XT, like IGS format, it should be ready. है ना. Number of cavities 2, 6, 4, or है ना, like 8 cavity, how much number of cavities customer want from the mold, right? In one shot you can say that, है ना. This is all the detail about that. See here, so this is the part detail, है ना? For a specific this component, I am showing the part detail. See here, part dimension is that average wall thickness is about 1.67 and a part weight is about 38.50 gram. Plastic material is PP, shrinkage considered 2%, part 3 data step and number of cavities 1. I understood. And now see part detail. So okay, design feature in product. See, what is the meaning of design features? Design feature that may be difficult or impossible to manufacturing, you can say that, है ना? Or difficult to eject from the mold also. That can be features, है ना? Features, right? See here in this component you can see that the red portion is the critical, right? For that we have to use the EDM machine, right or wrong? EDM machining, because that red portion is the ribs. See here. So for making this rib, we have to use the EDM machining, right or wrong? And if we are using the EDM machining, mold cost will be high because of that manufacturing, right? So we have to mention that rib and gussets, if possible, can we remove this rib and gussets if we not required? We can suggest to the customer, right or wrong? In order to reduce the mold manufacturing costing, we can suggest to the customer, right or wrong? Okay.
Yes, sir.
Huh? And draft
But
type.
here,
Yes.
one gassets we cannot remove.
But
Sanjay,
yes,
a ribbon gassets we cannot remove in this case.
we cannot remove. In this case, you are saying that. You are saying that we cannot remove the rib or gussets, right?
Yes.
Yeah, of course. But as I told you, this is critical. For example, you have a customer. So 1 minute. For example, 1 minute. Why I am telling you this point? 1 minute. See, for example, you have a customer, है ना? And the customer need one cavity mold. How much? One cavity mold, है ना? And in one cavity mold, or customer has a budget about only 1 lakh. How much? 1 lakh for one die, है ना? 1 lakh for one die. Is it clear? And this dimension is not critical for us. For example, this dimension is not critical for us and for the customer also. So there is no requirement for the rib or gusset if the dimension is not critical for the customer. For example, this is the toy component. This is the part, toy part. Toy part. Just for an example. Right or wrong? And customer has a budget about 1 lakh. Because of this rib and gussets, if we are using the EDM machining, the manufacturing cost will be high. Or maybe manufacturing cost with the design, or all the VMC and the CNC manufacturing, right? Because of that, a mold cost is around 1.2 lakh. Then, so we can suggest to the customer that, sir, we should remove this rib and gussets if you need the die into this budget, right or wrong?
Yes, sir.
Right? Okay. So basically, just rib or gusset, I'm showing the rib or gussets here, that this is the design feature or the features which can be increase the mold costing and manufacturing costing, right? So as I told you, we have to discuss with the customer. If the customer said that sir, we cannot remove this rib and gusset, it is very important, then we will not remove the rib or gussets, right? Because this is the critical feature for the component, right? Understood?
Based on the application, we can decide it. Master.
Yeah, we cannot decide. We have to ask to the customer about that. Okay, but we can suggest about that. For example, if the component need the strength for this dimension, we can suggest that, right?
Yes, sir.
Right? We cannot decide, but we have to discuss with the customer about these things. Right? Always. Understood? Sometime we have to manufacture the mold, we have to design the mold depending upon the customer requirement, right? For example, like a customer, we have a customer already has a plate size, for example, like 250 and the 200, है ना 200, and customer says that sir we need 8 cavity mold into this size. So this is the challenging thing, but we have to do because the customer is required these things, right? Because this is the customer requirement, right? So we have to design the mold depending upon the customer requirement, right or wrong? And sometime as I told you, right? Okay. So draft angle. Acha, what shows the draft angle? See, for example, this is the draft angle, right? And a green portion shows the positive angle, and the red portion is showing the negative angle. So basically, what it shows here? Current cavity region, you can say that, right? Right? Okay.
Yes.
है ना? Here you can see that. So basically, if I am selecting the draft angle, so basically we are selecting the parting line. Nothing but we are selecting the parting line. है ना? Where is the parting line of the component? For example, if the component is the critical, है ना? That's why. Wall thickness. See, wall thickness. So here you can see that if the red area here, so basically this is the maximum wall thickness here. है ना? This is the inner portion, right? And here you can see that average wall thickness about the component is about between 2 to 2.3, right or wrong? So average, you can say that it is uniform wall thickness right now, right or wrong? Right or wrong? What the color shows maximum? In maximum area, what color shows here? Yellow.
Average thickness.
है ना? Average. So basically it is you can say that there is a uniform wall thickness, है? between a quite range, you can say that, like 2 to 2.3 mm, right? So basically because of this average wall thickness, there will be, you can say that the warpage will be not here, right? Warpage defect will be not in this component, right? Understood or not?
Yes, sir.
Achha, A and B surface. Again, what shows the A and B surface? Same as the draft angle, right? So basically you can see that A surface is the cavity and B surface is showing the core, right? Mold draw direction. So basically I am showing the parting line of that. So for example, this is the flat parting line right now. Okay, so here you can say that this will be the fixed half portion and this will be the moving half. I am showing these three things, right? There is two things here, that the mold draw direction will be in this direction. Understood? है ना? अच्छा, tentative runner and the gate position. Now see, for example, customer says that we need a cold runner mold. Okay, so for that cold runner, we have choose the pinpoint gating system, right? And gate position will be on the mid and the center. Pinpoint gate with the cold runner. This is the customer says to us, right? है ना? So for that we have to discuss with the customer, as I told you, right? अच्छा, ejection analysis. Where will be the ejector pin? Tell me. Where should be ejector pin? If we are using rib and gussets here, if the customer requires, so basically we should use the ejector pin at this location. Right or wrong? Achha, if we take the ejector pin here, then
Will not come out.
nah, it will come out, but appearance
cost
will
will be high.
appearance. It is all about the appearance of the component, right?
Even it will cost more, no, sir.
Yes, of course.
In 3D, we have to get the ejection out.
Yes.
3D part.
So basically, this is you can see that this is in 3 axis, right? So basically, your ejector pin portion will be, or the your top portion of the ejector pin will be in curve shape, right? So then we have to take the D-lock in the collar. Why? in order to lock the ejector pin, right?
Yes.
So basically where will be the best position for the ejector pins? See here, this is the best position for the ejector pin because this is the single cavity, you can say that, right? Single cavity mold, eh? Or we will eject the component from the center portion, right? है ना? Molding defect prediction, है ना? तो we can predict the defect like sink mark, weld line, warpage or short, है ना? तो for that we have to use the mold flow analysis software, right or wrong, है ना? First of all, you have to show to the customer that what confidence of filling with the same gate which we are choosing. Like here you can see that confidence of filling is 100%, 100%, right? है ना? अंडरस्टूड, ठीक है.